Good morning, ladies and gentlemen. I feel sorry for you having to sit so close to all these unattractive people. This is kind of how things go. I said, give me the smallest room possible, because, why wouldn't it just be fun to hang out like our families do? Plus, it's Chicago, and everything here is tiny. I mean, it looks really big, like the conference, but my apartment is like the size of a shoebox. So today we're going to be talking about, I keep wanting to call it Watch Brent Tune Servers, Microsoft SQL Server Performance Tuning Live. If you want to ask questions live and you've got enough room to open your cell phone or tablet, you can go over to ignite.microsoft.com, search for that breakout code. I have the Yammer second screen up on my second laptop so I can see the questions that you ask. Although at least this room's nice and comfortable enough that you can just throw up your hand and stop and ask questions. Those poor suckers in the overflow room, they don't have that luxury. You snooze, you lose. So... And it's not all their fault, because it's really hard to get here from one session room to another. The theme for this conference is I would walk 500 miles by the Proclaimers, because that's basically what we're doing in between sessions. So a little bit about myself before we get started. I'm a Microsoft Certified Master in MVP, which just means I've made a lot of really expensive mistakes over the years, and now I help other people avoid those same mistakes. I've written a lot of tools and utilities, and I blog extensively over at brentozar.com. One of the few presenters here who doesn't work for Microsoft. They would never hire somebody like me. They just bring me in to present so that their employees look much smarter after my session is done. So we're going to start with a question. What is a fast car? When I ask you to think about what is it that makes a car fast, when we look at the car we drive versus the car we like to drive, how do we describe the differences between those two? And usually in my in-person classes, I ask people to turn to the person next to them and start describing that. But for now, I'm just going to ask you to stop and think for 10 seconds, because I could never get all of you people to shut up once you first start talking. So think for 10 seconds about what it is that you would describe a fast car with.
Engine.
So who said something? What? Engine. Oh, okay, the poor guy. Is he sitting on the floor? In the back? You can't even see me. Oh my goodness, that's probably, not being able to see me is probably the best seat in the house. So the way that most people will do it is they'll say, I'm going to go look at the dashboard on the car. This is a picture of my car's dashboard. The speedometer goes up to like 140 miles an hour. I guarantee you my car won't do 140 if you throw it out of a plane. But there's two numbers on there that are important. The speedometer in miles per hour tells you how fast that car can go. And the tachometer right next to it, the little thing that my wife likes to call it the volume meter, when it's all the way over to the right-hand side, the car's really loud. That's why she doesn't use the manual transmission anymore after the incident. The one over on the other side shows us in RPMs, how hard the engine is working in order to go that fast. Generally, we're used to glancing at the dashboard and seeing this all day long. We can tell you how fast a car is in terms of miles per hour. Now turn around and think about how you would describe a fast SQL server. Over and over again, when people come up to me at conferences, they say things like, I have a big database, I have a large table, my server goes really fast. And then I say, okay, cool, give me the numbers to describe that, and everybody gets this same blank look. Well, I never want you to have that blank look again. So here's the metrics that you're going to use to describe whether or not your SQL server is fast. First off, batch requests per second is how many queries per second your SQL server is handling. There is a similar perfmon counter called transactions per second. As it turns out, not every query is a transaction. So even though it sounds more accurate, it's actually less accurate. Batch requests per second is your SQL Server speedometer. Second down there is wait time per second. For every second on the clock, how many seconds does your SQL Server spend waiting on stuff? You want to memorize these two things whenever you're dealing with a SQL Server so that when you go to ask somebody, how do I make this SQL Server go faster? It's a lot like going to a performance tuner and saying, I need my car to go faster. If you tell them it's doing about 30 miles an hour, after they stop laughing at you, they're going to tell you to just, fix the flat tires on it, and you're going to be able to go dramatically faster. So I'm going to show you how to measure these, and we're going to take a few workloads and change SQL Server features to see how they affect those numbers. Today I'm going to be using the Stack Overflow database. How many of us have seen stackoverflow.com before? Okay, so for those of you who haven't, it's a website where you post all your hard questions about technology, someone else does the work, and you get to claim all of the credit because your boss hasn't heard about this website yet. One of the cool things about this is they publish the whole database under Creative Commons, so you can actually download it to your laptop and use it for demos. I love Microsoft, but I never want to see another Bicycle Adventure Works demo again as long as I live. Like, that's like the most boring data in the world to me, whereas I love looking at Stack Overflow questions because I can see things about technology. I'm going to be using SQL query stress, and I'll show you how that works, and I'm going to talk you through how I gather these metrics. We're going to start in and jump right into the demos. So I'll switch over here, and now I have SQL Server Management Studio, and I am running SQL Server 2014. I was hoping that I'd be able to show you 2016 today, but then again, you guys have been bombarded with all kinds of stuff that you're never actually going to be able to use in production for the next 2 years, and by the time it comes out and your company's willing to use it, you would have changed jobs anyway. So we're going to just be talking about stuff you can actually use today. I have on here, you know it's true. I heard the guys who are laughing the hardest, they've already got their resume out on like monster.com. So I've got on here the Stack Overflow database. It's got things like users, questions. Questions are just commonly hidden as posts is the way that they're described here. Votes is how we vote up and down answers over at Stack Overflow. Tags on questions, like is it a Windows question, a Linux question, and so forth. Everything in this demo script you guys actually have as part of my Ignite resources. You can go download this and play along with it at home when you get back. Now, of course, you're going to see different performance numbers on your machines because you have different machines than I do. That's okay. It's still good for troubleshooting purposes. I've got a link in here explaining how you go and get the Stack Overflow database. It's about 60 gigs when over your end done and all set up. So now, normally you'll see presenters cripple their laptops. They'll give it like 1 gig of RAM or 1 core. I'm taking off all my virtual servers handcuffs today. I'm making sure that I have all my cores available, and I'm even doing some best practices setups like setting my cost threshold for parallelism to 50. I've got reasons in there inside the query notes as to why I do this and why I recommend everyone do it just as a good practice for first getting started. So I'm going to go through and run a bunch of scripts just to make sure that my SQL server is always up and running or is ready to go. Because being a presenter, very often we leave our virtual machines in nasty states. Now I'm going to pretend that my whole SQL Server's mission in life is just to run this query. I'm going to show you harder and harder workloads as we go on, but in the beginning, I'm just going to run this one. Go get me the total number of users or the total number of reputation points for all of my users in a certain date range. Now, when I run this, when I hit execute, it finishes pretty quickly. I'm going to bring up this so you can just see me run it over and over again. It seems like it's going pretty quick, so my end users should never complain. Unless I hit the gas pedal, unless I start doing 1,000 of these per second. Over at Stack Overflow, we do 2,000 to 5,000 batch requests a second all day long. So a query that takes a second may not really be acceptable. So I need to be able to simulate load, really hammering this query over and over again on my SQL server. I'm going to show you the tool that I use to do it, and it's totally free. It's Atom Mechanics SQL Query Stress. SQL Query Stress will run any query that you want over and over again against your SQL server. So what I'm going to do is go click the database button, and I'm going to tell it I want you to hit SQL Prod 1. We're going to use my built-in account. I could also use SQL authentication if I wanted to. And then when I hit the drop-down here to test it, it lets me pick which database I'm going to run in. I'm going to run it in the Stack Overflow database. And I'm going to click test only because my tests always succeed, and I like for things to work for me every now and then. I'm going to click OK, and now I'm going to tell it what query I want to run. So I'm going to switch back over here into SSMS. I'm going to copy that all back out. because I was never smart as a boy. I never learned to Alt-Tab correctly. And then I'm going to paste back out over here. So now I have the query in SQL query stress. How many times do I want it to run? Let's do 100,000. And let's do it across, say, 20 threads. When I hit go, SQL query stress shows me the number of queries that have completed. That's the iterations completed area over here on the right-hand side, and gives me statistics about how long this query is taking. Now I need to start measuring my SQL server and figure out what's going on with it. Is it coping well with this load? If you were near the podium, you could probably hear my laptop start to hover because the CPU fans will be going on here pretty quickly. My CPU's jump straight up to 100%. Well, of course, we don't really want to do troubleshooting by using Task Manager over a remote desktop, right? That's where one of our diagnostic scripts comes in. Let's go take a look at something called SP Ask Brent. So I'm going to run it, get way down here. And you'll notice in the demo scripts, I've got all kinds of comments in there. It's like me talking you through the demos as you go through and run it later. SP Ask Brent, what it does is it takes a 5-second snapshot of what your SQL server is doing. How many things like, or high CPU utilization? If you use my SP Blitz, how many of you have used my SP Blitz before? Okay, cool, you're my people. The rest of you, not so much. I'll tolerate you anyway. It gives you a prioritized to-do list of the problems on your server right now. Same thing here. The first result set says this is the version of SP Ask Brent. The second one says, hey, Bozo, you have high CPU utilization. So what exactly is high? Let's go take a look. 83%. So my SQL server is running an average of 83% right now. And I get my dashboard numbers here. It tells me that right now my SQL server is doing 15 batch requests a second, or as you could think of it as 15 miles an hour. It also tells me how much wait time I have. For every second on the clock, every core is waiting for 3 seconds. Now, if you go to the URLs across each of these links, it'll give you more details about how to interpret each of these metrics. But for today, I'm just going to think of it as 15 miles an hour and the car's doing some weights. If I was really good, I would go off and do query performance tuning. I would figure out what's broken about that query and try to fix it. But how many of us can't control the queries that run on our SQL server? Right, a lot of times the developers just tell us to shut up and deal with it, right? It's worked fine on my machine. So, right, you have the same users or same developers I have. Microsoft has kept execution plans pretty much the same since SQL Server 2005. One of the really cool things about Microsoft is they would rather give you a stable SQL server than give you an unpredictable one. They would rather not change the engine willy-nilly with every version upgrade. This is why when you go and do upgrades, you don't really stress out about query plans. You stress out about doing things like backup and recovery, or maybe how full text search changes. But they've actually been really hard at work improving execution plans since 2005. They just don't show the improvements to you by default because sometimes they're better, sometimes they're the opposite of better. As it turns out, my particular query plan has an interesting thing going on with it. If I go look at my query, I've got this query, and I'm going to go get the estimated execution plan. SQL Server's going, hey, man, I'm going to do a clustered index scan. I'm going to go scan across the whole entire table. Even though I have indexes that would make this run faster, SQL Server decides to choose not to use them. Microsoft knows about this issue, and they've built it a fix, and I can turn that on. Let me show you how. With something called a trace flag. Now there's a trace flag that you can turn on, $41.99, and I see people writing down, hold your pens, because things will get a little bit more interesting here in a second. When I turn on 4199, it gives me some of the execution plan improvements that have happened since 2005. They're not on by default, but I can turn them on as long as I know what they're doing. It's like a break glass, bang the switch kind of thing. So let's go break the glass and turn that switch on. But before I do it, I want you to get a good look at SQL query stress and kind of notice how the numbers are moving. So look at that iterations completed, and it's 2400, 2430. It's not particularly moving quickly. Let's go ahead and make use of all this beautiful screen real estate. Man, Microsoft did a good job with the projectors here. Over on the right-hand side is my iterations completed. I'm going to go turn on that trace flag. Boom. Yeah, that's kind of cool. So I have to be really quickly. Normally I would zoom in on that and wait for a while, but I got to go run SP Ask Brent to make sure I catch something kind of quickly, because I want to go look at my speedometer, but in a second I'm going to run out of road. I am now doing 9,000 batch requests per second. How many people like that better than 13? Yeah, right? Now, I am not saying you should turn that on all across the board, and boom, there goes SQL query stress. I'll go ahead and stop that guy. The other thing that's interesting with that is when I go through and look at the execution plan for it now, let me go back and find my query, go see my execution plan. Hey, wait a minute. It's not prescribing me a missing index anymore because there was an index there all along. SQL Server just decided not to use it. Now, I know what you're thinking. First thing, I can get to a computer and a VPN. I'm going to go turn on trace flag 4199 across the board. Hold off. This is one of those carefully crafted demos where I think about SQL Server as a pie chart. Different workloads respond differently to different things. I'm going to give you a few tools that work for small pieces of the pie chart. In a perfect world, you would turn this on in a dev environment and test your ugliest queries there first to see if they made a difference or not. But let's be honest, most of you aren't going to do that. You're all, do it live, because that's how you roll. I know, yes. This is why people come to my sessions, because it hurts so close to home. So the thing that you need to know, and one of the reasons that I'm not such a big fan of trace flags, is that you are getting an untested or less tested branch of the SQL Server engine. There are known problems with trace flag 4199, and I'd rather not turn it on by default. For example, cannot bulk load when I turn on trace flag 4199 and 610 running SQL Server 2014. So I'm not a big fan of trace flags, and instead I'm going to show you something a little bit different. I'm going to turn off that trace flag and zoom back out. Now, normally when I go look at database properties, if I right-click on database properties and I go into options here for the Stack Overflow database, there's this compatibility level drop down that everybody always gets drunk and plays around with. They don't really understand what it means, and they go, as long as I leave it on an old one, my vendor will never know that I've moved to the cloud, or things like that. For a long time, this has only influenced the way that T-SQL gets interpreted. It didn't really influence performance. But starting with SQL Server 2014, when you switch to the new compatibility level, when I change this to 2014 and hit OK, I get the new cardinality estimator plus other improvements to the way that execution plans are built. Just by changing that, I can suddenly get different query plans. I love this when I can't control the queries, because my developers will often say things like, and my third-party vendors will say things like, you can't turn on trace flags, that's unsupported. But then when I ask them about things like compatibility level, they're like, well, sure, I guess. We've never really tried that. Awesome. The less you know, the better. So we'll say OK. Now what I've done is I've turned on compat level 2014. And I'm going to run this command dbcc trace status. This just shows you that I don't have any trace flags hidden up my sleeves. There are no trace flags turned on right now. I don't have any trace flags turned on. All I've done is set compat level to 2014, and now when I go run my load test, I get the same improvements that used to be bundled under the trace flag. This thing is flying now, even though I don't have the trace flags turned on. Woo, SQL 2014, out-of-the-box better execution plans in 2014 compatibility level. If you're one of those database administrators that's always left that as non-functional, not really touched it after an upgrade, now is time to start paying attention when you go off and implement this guy. So let me show you the takeaways on this, because I like to type all this stuff out, because some people are verbal, or some people are visible. So if you're on SQL Server 2012 and you're not allowed to upgrade, and you do have the time to do some testing, play around with trace flag 4199 and see if it makes your ugliest queries go faster. If you don't, get on SQL 2014 as quickly as you can. Do not turn the compat level to 2014 immediately. You know how it is with your users. Anytime you change anything, they're going to blame you for everything that happens afterwards. So I want to minimize the number of things I'm changing. I want to leave it in the old compat level when I first do the upgrade. And then about 2 weeks later, when the partying is stopped and everybody's not worried about continuously breaking and fixing things, then I'll go switch it to 2014 compatibility level on a weekend and see if I hear anybody screaming. Because sometimes query plans can actually get worse instead of better. This is why I want to change it over a weekend rather than doing it on Monday morning. Now, what's tough is, unless you've got really good monitoring software, it's hard to know which queries got better or worse. This is where the next version of SQL Server 2016 has something called the query store that will track what they call plan regressions. I'm not going to go into depth in this here. I've already written about it on the blog, and you can play around with it when the CTP comes out in the summer. The beautiful part is you'll be able to spot quickly which queries got better or worse, and you can pin the old 2012 execution plans to them without doing anything with your developers. You can simply jump back to a better performing execution plan for that one query. Any questions about this piece so far? You're all wrapped in paying attention. Oh my God, you're all still thinking about the trace flag, and no one's done anything on Yammer either. Okay, cool. So that's one workload, but now I want to look at a different workload. What I have here, let me zoom out a little, is a reporting system built atop Stack Overflow, and I have things like show me which users do which kinds of queries on which kinds of tags. So this report users tags table is really wide. It has all kinds of columns. This is what a data warehouse fact table looks like. There's like a couple of keys and then a gajillion measures, questions, answers, questions last year, questions this year. And I can never predict what my users are going to query. They query any number of these columns trying to do analysis. I'm going to show you what the data looks like first, and then we're going to go run a couple of analytical queries. So the top 1,000 rows out of this table, just to show you, says things like for user ID 26837, here's all the tags he's played around with. He's 41 years old. I'm not happy about that, but I had a birthday and these things go on. The number of downvotes I've done, where I live, my website, all kinds of statistics about my answers on various tags. Well, what my users like to do is they like to run queries that look like this. And I'm going to zoom in to show you while it runs. It's going to take 30 to 60 seconds for this thing to run. Show me, for every tag, how old are the users? People who use this tag very frequently, how old are they? And think for a second, if you use Stack Overflow, what kinds of tags you're going to expect to see come up there. Now, as you can kind of expect with a data warehouse system, I'm running up against 30 seconds here. This is normal for what a data warehouse does. Data warehouse reporting queries take like 30 seconds, 60 seconds, and our users are usually just happy if it takes less than 5 minutes. They go, just please make sure my reporting queries don't time out. They're not happy about these kinds of run times, but they're willing to live with it. So our results? As it turns out, the oldest users do things like legacy code, Visual Source Safe, Delphi 2010, and legacy. Okay, so that kind of makes sense, really old stuff. Not many of you are laughing. It's okay that you're older than me. And we'll go on to the next query that's out of here. Similar kind of analytical query. Which tags users have the lowest reputation? So if you go in and do certain kinds of work on Stack Overflow, what are the kinds of users that never get upvoted? Maybe what are the tags that people don't appreciate very much? Same thing, this thing's going to take about 30 seconds in order to execute. 19 seconds. We'll take 10-second bio break here. Bio break's the wrong term. That sounds like you're going to the bathroom. It's a tightly packed room. Please don't do that. But those of you in the overflow room, go right ahead. So now we see the top 10 or top 20 tags, the ones that are unappreciated that people don't seem to like very much. Wow. Okay, that's cool. I understand. It's whatever. I don't make this stuff up. All kinds of similar questions, and they always take about 30 seconds. And when I look at those queries, if I go back in there and take a look at the kinds of queries that we're doing, it's really hard to index for these because the selects are different, the wheres are different, the grouping bys are all over the place, the order bys are all over the place. So SQL Server has introduced something that is amazing for those kinds of queries. And I'm going to go run I'm going to skip that one. I'm going to skip that one only because it's not fair. Let's do something else. There's Microsoft people in the room, and there's some things I don't want to show. I might show that later if we have time. So I'm going to create something called a non-clustered column store index. Normally, when you create an index in SQL Server, you don't want to include very many fields in it, right? You've seen the kind of indexes the Database Tuning Advisor tells you to create. They have like 100 fields in them, and then you create that index and everything goes slow. Non-clustered and clustered column store indexes are different. It's kind of like creating an index for every single column, but this index can be used together so that when my users query just 5 out of these 50 fields, SQL Server is able to jump directly to the individual columns and only get the data that it needs. I like to think about everything in SQL Server being stored on 8K pages. Think of it just like a spreadsheet page. It's got all of the columns on there, but half the time I don't want all of the columns. They're really crappy columns that I had to use because the data warehouse team made me. So what this thing does is it creates a different copy of the table stored in a different kind of way. While it creates, because it's going to take about 3 minutes in order for this thing to get created, I'm going to copy something into another window and show you a little thought exercise with this. If I created an index for every single column, how well is that data going to compress? If I look at the first column, user ID, all the fields are the same. Well, there's going to be all of the users are in this table, but any one user is going to have hundreds of records in here. So I could just store that once and compress it massively. This column for tags, it's not going to compress very well. Age, all these other columns are going to compress beautifully. With column store indexes, it's not unusual to get a 90% compression rate on your data warehouse tables. You know that terabyte table that sounds like it's so very big now? What if you could get it down to just 100 gigs and cache the whole thing in memory? All of a sudden, performance looks completely different. Now, in my particular database, we'll look at the sizes on these as this guy finishes. He's still going, which tells you something else interesting about column store indexes. When in SQL Server 2012, how many of us still are only working with SQL Server 2012? And it's okay not to be ashamed. I mean, it's okay to be ashamed. Whatever, you're all ashamed. You're in my session. The problem with 2012 is that when you create a column store index, it immediately makes the table read-only. How many of you can have read-only tables? There's a lot less hands going up. It could be useful for data warehouses where you load everything in a batch process at night. It actually turns out to be amazing for that. Starting with SQL Server 2014, you can create a clustered column store index that is updatable, which is perfect for your data warehouse fact tables. And also in SQL Server 2014, non-clustered column stores that used to be like read-only in 2012, they're still read-only in 2014. But that's okay, because starting with SQL 2016, then those suddenly become writable. So now this thing is created. It took 2 minutes and 48 seconds. Let's go take a quick look at the table first. Let's right-click on my table here, Report Users Tabs, and go to Properties, Tags, and look at Storage. Data space. This is how big my reporting table is, 32 gigs. The only index I have on that table, the non-clustered column store index, has all of the fields on it, and it's less than 1 gig. This is magical for queries that are doing reporting stuff. Suddenly, I can fit the whole data set in RAM, whereas I couldn't before on this crappy laptop. And of course, I'm just saying that because it's a Microsoft conference. It's actually an Apple laptop, but I digress. So now, let's go back and run our query again. So remember our oldest users query? So this is the one that tells me how old our oldest, which popular tags users are the oldest. I'm going to hit execute, and I'm going to zoom back out, and I'm going to have to move the results pane around, and you didn't clap because it went so fast. Let's try again. Execute. This used to take 30 seconds, 2 seconds. Oh, you're just doing that to be nice now. It's not like I wrote the code. And then we'll try another one. We'll try one of my other ones. Which users have the lowest reputation? Let's go execute that. Boom. Done in less than a second. Boom, 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 boom. Boom, 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 boom. Then going on down to the other one that I didn't even have the time to run. Boom. It's done just that fast. This is the magic of column store indexes, and they truly are amazing if you have the right use case. So what is the right use case? Let me jump up and show you here. Here's where they make sense. This section right here. If you have a data warehouse type server where the biggest weights are waiting on storage to deliver all of your data is too big to fit into memory, you have really wide tables and you only select a few columns of those, and your users love doing grouping and aggregation, non-clustered and clustered column store indexes can be pretty awesome. In this I can't talk about column store without plugging this guy. Nico Neubauer, he's Portuguese. See, I can barely even say Portuguese, let alone what his last name is. Nicoport.com column store. This guy has an over 50-part blog series explaining all of the internals with column store indexes and how they work. Fantastic series of blog posts. Then SQL Server 2016 gets even better. Here's the improvements in 2016. You can finally update your non-clustered column store indexes. You can put regular indexes on top of clustered column store indexes, better sargeability, all kinds of really interesting improvements, and one of my favorites, being able to query them on always-on availability groups, secondaries as well. Any questions about columnar indexes? How many of you want to go back and play around with that when you get back to the office? Yeah, awesome stuff. I also put a link to one of the breakout sessions just dedicated to column store. Ignite has already put up all of the videos on there. So now, I've been doing a lot of reads. Let's do something a little bit different. What about workloads that are very write-heavy? In Stack Overflow, everything is considered a post, whether it's a question or an answer. Anytime you ask something on Stack Overflow, we call it a post and it all goes into the post table. And then on the side of Stack Overflow, we actually track the view count for every question, which sounds ridiculous. You know, a lot of us use things like web analytics. I'm skipping a vendor's name here that shows you how many hits your web pages get. At Stack Overflow, we actually track that stuff inside the database. We have view count materialized in the database. You get to see that. You can imagine on a website that gets 2 to 10,000 hits every single second, updating that sucks. You don't really want to update that live in the database. And of course, at Stack Overflow, we don't. Every time you hit the database, we don't, or every time you hit a website, we don't directly update the database. We queue those up. But that's because the Stack Overflow developers are way smarter than your developers. Your developers are probably hitting the database every single time somebody hits the website. So let's pretend that our developers up here are as bad as your developers. I know it's hard to comprehend, and you came to this session in order to get away from that kind of thing. So if I go through and I have this stored procedure, update post views, it goes through and bumps the number of views on a post every time I run it. Let's go get our buddy SQL query stress and hammer the daylights out of this to see what happens. If I go copy paste this out, and I jump into our buddy SQL query stress, I know, it makes me cough too. So I've got that stored procedure in there now, and I can go off and hit go, and it's going to run. It's doing a decent clip. I'm getting a couple thousand a second, most likely, if I go in and look at that. It's trucking right along. Let's go in and run SP Ask Brent to see what this thing looks like. Now, I've added a different parameter in SP Ask Brent for this one. I'm turning on expert mode only because it gives me a little bit more information. It doesn't do extra checks. It just reveals more information about the checks that it did. Remember we talked about our speedometer being batch requests per second? We're doing 11,000 miles an hour, which is awesome. I'm pretty happy with that. But I have a wait type called write log. My SQL server is being bottlenecked because it can't write data to the transaction log fast enough. The reason that I turned on expert mode here is that SQL Server will give me, or that Ask Brent will give me more detailed information saying, for example, we waited on this thing 23,000 times in order to write to the transaction log. Normally, when people say, I need to make my transaction log go faster, they go knocking on the SAN admin's door. That's usually not very effective, right? They throw us out and then they go off to their BMW and drive over to the steakhouse for lunch because SAN admins seem to make a lot of money. A lot of us are probably used to having the 15-second I/O warnings as well. Your I/O has taken more than 15 seconds in order to complete. In the past, our guidance for fixing write log waits was just to make your storage faster or write less to the database. But starting in SQL Server 2014, there is an amazing button that you can push. Of course, I love pushing buttons, so let's go do it. Check this little command out. Alter database set delayed durability equals forced. When I run this, what SQL Server is going to start doing is considering your transactions committed even though they haven't hit the transaction log. A lot of you are probably thinking that's dangerous. You're right. You get a gold star for the day. This isn't something that you want to use for financial transactions, payroll, gambling, whatever it is that you, maybe with my gambling record, you probably do want to erase all records of your history. But let's go ahead and cancel this load test going. He's really churning right along there. And let's go change that database. I got to move out of it in order to change it. Let me switch over to master and run it. All right, so now I've gone through and I've set it to delayed durability. This is also something that I can see at the database's options screen. This is database level, not server level. So I can set it for just my crappy databases that I don't really care about. Now, let's go back through and run our transaction load test again. Go. And run our SP Ask Brent again, which will take about 5 seconds in order to check out its results. Now, before we were doing like 11,000 miles an hour. Now we're doing like 12,000 miles an hour, which is better, but not dramatic, right? But the interesting thing is, my wait stats no longer say anything about write log. because SQL Server just isn't even bothering waiting for my transaction log to say we're good. It's just going, yep, the view counts are right, get out of here and go on with the next transaction. This is only good if you have data that you're willing to walk away from, and write log is your biggest weight. For stuff like view counts, this is perfect. Who cares if I lose 30 seconds worth of page views on a database? This is also perfect for things like data warehouse staging tables, where you're just going to do the whole load, and if the server crashes, you could just restart the load again anyway. You're probably going to have bigger problems. But there's a gotcha in here, and I have to say it because it's really important. You're okay losing transactions even when you gracefully shut the server down. Whether you accidentally shut the server down or you gracefully shut the server down, SQL Server does not guarantee that your transactions are going to hit the transaction log. Even if you just fail over a cluster, even if you do it manually, the only way you can really get around this is to run a command that flushes all your transactions and hope and pray no one adds a transaction before you shut it down or fail it over, which isn't very realistic. So what some people will do, and is totally valid, I'm not just saying that, you have a different option for delayed durability. Delayed durability can be allowed, but not forced. So that if you have crappy transactions you don't really care about, like updating view hits, what you can do is add that in your stored procedure to say, I'm going to commit this transaction with delayed durability on. This one is flushable, meaning who cares, we're going to flush it down the drain if we happen to fail the server over, whereas the rest of my transactions still get the good stuff. They still only get persisted when they actually get committed to disk. It's a really slick solution, but only when we have that data that we're allowed to walk away from. For me, because I really care about this data, I'm going to turn that back off for the rest of today. I'm going to switch back to, whoopsie daisy, I'm going to switch back to regular. So now I have delayed durability is turned off altogether because I'm not particularly concerned about losing my data here. All right, any questions so far? No. All right, good. I'm not saying you people aren't smart. I'm just saying that I'm a really good explainer. All right, so the next thing that we're going to do is we're going to run what I call a noisy workload. I've been showing you really simplistic ones so far. Oops, so I got to cancel. Did I cancel him? Stop working. I'm going to, this is one of the things with SQL Query Stress. It is a little buggy. It's actually really buggy. And sometimes you have to force task. SQL Query Stress, add a mechanic. If you're watching this, cover your eyes. Oh, it's not that I'm killing your children. Just you never really kept that child up to date anyway. So I'm going to go in and now run something that I call my noisy workload. I have one stored procedure, but it's actually calling all kinds of other random stored procedures because I want to make this server look like the crazy one you have back at the office. I have in the notes details on how you can mimic this exact task because I want, when I go and look at the SQL Server, I want a server to look like it's got all kinds of crazy things going on and all kinds of crazy different weights. So let's go through and run him. He's not particularly fast. There's your first warning that things aren't going pretty quickly. And I don't even have to look at the speedometer. I'm going to look at another tool, Atom Mechanics SP Who is Active. How many of you have not seen Who is Active before? Okay, so for those of you, if you don't bring anything else away from Microsoft Ignite, that conference ticket just paid for itself. You've probably been using SP Who, which is built into the product, or heaven forbid, Activity Monitor, which is like bell bottoms in that no one should ever see you like that in public. SP Who is Active instead does what it says on the tin. It gives you the list of active queries, and then you can click on any one of them. So I'm going to click on one, and it gives me the exact query complete with the formatting in the way that the end user sent it in. I can also do things like look at where it's coming from, which login it's using, who's blocking it, how many reads and writes it's done, what its current status is, where you go to break legs, like which host it's coming from. In this case, everything's coming from my laptop. When it started, which crappy application it is. I'm not saying .NET is crappy. It's actually awesome. It's just that my queries are really crappy. So I'm running SP_WHOISActive to see what's going on my SQL Server right now, and it gives me the oldest queries to the newest. So it's saying these queries have been running for like 16 seconds. These have been running for only a few seconds. I can execute this really quickly a few times to get a really quick idea of what my server's load looks like. And I can see in here in this wait column what these queries are waiting on. You don't have to be a Microsoft Certified Master in order to guess that LCK probably means locks. One of these queries is holding locks that a bunch of other queries want. If I look at the first query in that list, which happens to be the blocker, I can identify the blocker by looking at this session ID over here. Let me shrink it a little so I can get everything on one page. These guys are being blocked by 65. These guys are being blocked by 67. Here's 67. This 65 guy here, he's not waiting on anything, and there's no one blocking him. As it turns out, he's doing an insert into a table that everyone else wants to read from. It's really common in SQL Server to deal with blocking problems with some crappy query that's holding a lock on the entire table, or we've got multiple people trying to read from a table that everybody else is trying to write to. SQL Server ships with something called pessimistic locking turned on. It wants to be really, really careful. But since SQL Server 2005, there's been an awesome option, optimistic locking. Let me show you the command that's involved in order to configure this. Zoom down a little bit so you can see it. This guy right here. For Stack Overflow, we are going to turn on something called Read Committed Snapshot. As soon as I turn this on, readers won't block writers, and writers won't block readers. Think of this podium as my table. Think of it as the phone book, the white pages of the phone book that your grandpa used to have around on the refrigerator back before the intertubes. And it's organized by last names, so Adams, Bellman, whatever all our names are. Beck, I should have said Beck. See, there you go. So A, B, C, D, E, F. If I'm reading through that table and I get to Jane Doe and Jane Doe has a lock on her row, I may have to wait for a second. Read Committed Snapshot, when I turn that on, as SQL Server's got a lock on a row, it makes a copy of the original row over in TempDB along with the timestamp. So when I'm reading through the table and I get to Jane Doe, I go, oh, this has a timestamp that's newer than when my query started. I can go look over in TempDB, see Jane's row as of the time my query started, and then keep right on going, even though there's a lock on Jane Doe's row. Jane's row. Boy, then the political jokes start. Now, the challenging thing with this is that I have to get everybody out of the database in order to do this. So I'm going to cancel that query, and then I'm going to change that setting about Stack Overflow reports. Now, if I get hung up here, that means someone else is in the database. So this is one of those times where SP_WHOISActive comes in so insanely useful. I can go SP_WHOISActive. All right, here's my query. I'm trying to do an alter database. Someone else is blocking me with a SPID of 55. You just want my coffee, don't you? I see how it is. Now he wants my laptop. Oh my God, there's a robbery in progress. Yeah, you can yank that. You can totally yank that. So someone is blocking my SPID. Query 54 is blocking mine. So I'm going to do exactly what you would do. I would say kill 55, execute that, and now his query's out of my way, and mine finished successfully. Oh, that one's mine. Seriously, that's mine. It might be the other one guy. The other one might be somebody else's. Yeah. And there's a bag under there too. It's like a salvage sale. I see how it is. Tell Sherry, by the way, she did a great job despite all the AV gremlins. Woohoo! All right, so I now set on my alter database read committed snapshot with no wait. Now I magically have turned this on. And if I go back over and run my load test again, so I'm going to go fire off and go with my noisy workload, you'll see it's moving faster, but not necessarily dramatically faster. Let's go look at SP who is active again to see what's going on. So SP who is active. And of course, because I run a case-sensitive SQL server, I have to get it exactly right. So now, before when I was running this, you saw a blizzard of lock weights. You saw all kinds of them. Now, you only see a few. The selects are going through without a lock, but writers still block writers. So in the example I have here, the top guy is doing an insert. The next three are doing deletes out of that same table. I can't fix that. I can't have multiple people modifying the same rows at the same time. But now at least I've gotten the selects to not be a problem at all, and I've simply vaporized a great deal of my locking problem. A lot of other database platforms ship with this feature on by default. It's amazing, and we're just as good as they are. We just want to make sure you know what you're doing before you turn this on. And we've got a great set of resources online showing you how that works. Let me go jump over here. So here's when you turn that on. You turn it on when your biggest weight type is locking, you can't fix the indexes or the queries, and you're okay with the risks that we explain at /go/RCSI. Some of them include, for example, your TempDB is going to suddenly get a lot busier and can get larger too, because you need enough space to store the version store. You need to store all the copies of the rows that you're constantly changing. So TempDB may not have been a problem before, and it may suddenly be a problem when you turn on RCSI. I don't want to warn you away from it. It's not terrifying. It's not a huge workload. It's very rare, like 5% of the time when I've seen turning that on cause a problem. You just want to know about that before you go in and turn it on. So we covered a lot of stuff today. We covered trace flags, column store indexes, all kinds of fun stuff. On that link, I have a copy of a presentation for you to go take home with you when you go back to the office, summing up what I just said here, because I want you to be able to go back and explain the changes that you want to be able to make. I also have a recap of the NDA type stuff that was revealed about SQL Server 2014 during this week. So it's kind of a what's new with SQL Server 2016. It is licensed public domain. I am giving it to you to do whatever you want. Those of you who are consultants are free to take my slide out even and pretend like you wrote it and add in all those awful clip art pictures that you like to use. I know, I see how it is, and crazy fonts. So that sums up. Let me switch back over to the display here. Oh my God, my demos actually worked, even though there was a strange man up here fondling my laptop. So. Oh, my poor baby. So that sums up everything that I wanted to teach you guys about here today. What questions do you have about me before about SQL Server? I guess I could answer questions about me before you guys break off and take for a lunch. I'll do like 5 minutes of questions and then just let everybody vaporize. I will still stay here even after that. Yes?
With the last section you went over, if all my developers are putting no lock on all their queries anyways.
Yes. If all my developers say with no lock on their queries, is it the same as RCSI? The problem with no lock is this. Remember I was looking at Jane Doe? I had this thing going across. I can see Jane twice. Let's say I'm reading through and Jane hasn't updated anything. After I read past Jane, she gets married and moves to Smith. I can see her twice. Or I can see her not at all. So I can start running at the beginning, get past the D's, and Miss Smith can change her name to Doe, and I'll never see her. There's all kinds of gotchas with no locking. I like no locking, nothing wrong with it, but RCSI helps you get accurate query results better than no lock does. The crappy thing is, if you switch into RCSI without changing the developers to take off the no locks, they still get dirty reads, even though there's a perfectly good copy of the data for them in TempDB. SQL Server's like, you want dirty reads? I'll give you dirty reads. So, yes, next question. No, you're all good. All right, well, thanks everybody for hanging out with me. Go have lots of fun eating those box lunches, and I will see you guys around again.